4.6, formulas. You'll be able to determine area and perimeter of a rectangle in a total value formula. Use formulas to solve various types of problems. Translate an English sentence into a formula and solve a formula for a variable. So recall from chapter 3.3 that a formula is an equation that contains two or more variables. We can use formulas to find quantities such as the area and perimeter of rectangular objects, the total value of a group of objects, and the average test score of a group of tests. Recall from chapter 1.1 that the area of a rectangle is equal to the length times the width. In other words, A equals L times W, where A is the area, L is the length, and W is the width. In general, to find a single value of a variable in a formula, we often substitute numbers for all the other variables and then solve for that single variable. Let's look at an example. An architect is designing a school building so that each classroom contains 35 student desks. Fire code requires that there be 18 square feet per student desk. If there is enough room for classrooms of length 28 feet, what is the smallest width? Okay, so let's keep track of the information that we have. I like to use a cursive L so that I know it's not a 1. So we're told that the minimum length is going to be 28 feet. We're trying to find the width, so we do not know W. That's our goal we're trying to find. But we can calculate the area we need. We want there to be 35 desks to each classroom, and each of those desks requires 18 square feet. So the area needed per student desk per the total classroom, not per student desk, per the total classroom, would be take the area required per desk times the number of desks you want in the room. So 18 times 35 gives us 630 feet squared. So in our formula for area that's written above, area is equal to the length times the width. Let's fill in the information we know. We just said we know the area that's required is 630 feet squared. We know the length is 28 feet. We do not know W. That's what we're trying to find. So to solve, we learned in 4.3 and 4.4, we want to get the variable all alone, and we use inverse operations to do that. So the opposite of multiplying by 28 is dividing by 28. So I'm going to divide both sides by 28. And this does not divide evenly. In your calculator, when you do 630 divided by 28, you get 22.5. So the smallest width would be 22.5 feet. In order for us to meet those fire codes. The perimeter of a polygon, which is a geometrical object such as a triangle, rectangle, or trapezoid, is the total distance around the object. So specifically for rectangles, area is length times width, whereas the perimeter is 2 times the length plus 2 times the width. And you could even visualize this with a picture. So if we have a rectangle with our length and our width, well, there are 2 lengths and 2 widths, so the distance around that rectangle, that's where they get 2L plus 2W, because we would take L plus W plus W. And that's how they came up with the perimeter. Let's look at an example. A landscaper has budgeted enough money for 100 feet of fencing to enclose a rectangular garden. So he's enclosing it. This number is talking about a perimeter because we're talking about the distance around something. Oops. So I know I'm dealing with perimeter. That's what the 100 is. If the length of the garden is to run the full length of the property, which is 37.5 feet, so again, we're given the length, 37.5 feet, what will the width of the garden be? So let's think about the information we're given and the information we're trying to find. We're told the perimeter, 100 feet. We're told the length, 37.5 feet. And we are trying to find the width. That's the variable we're going to be solving for. So if we have our formula, perimeter is equal to 2 times the length plus 2 times the width, let's fill in what we know L and P to be. P perimeter is 100 equals 2, and then instead of writing L, we're going to write what L is equal to, the 37.5, plus 2W. So before we can solve for W and get it all alone, we do in fact need to simplify. We can multiply 2 times 37.5 to get 75. So 100 equals 75 plus 2W. To get W by itself, you need to get rid of addition and subtraction first. So I need to get rid of this positive 75 by subtracting it to both sides. So 100 minus 75 gives us 25 equals 2W. To continue to get W by itself, we need to get rid of the multiplication between the 2 and the W, and the opposite of multiplying by 2 would be divide by 2. So we're going to divide both sides by 2. In your calculator or by hand, 25 divided by 2 is 12.5. So the width of the garden will be 12.5 feet. And I'll probably divide this into 2 videos because I'm worried it'll be too long to upload. So let's finish this next page. If n objects have a value v, then their total value, capital T, is given by T equals v times n. We're going to use this on the next problem. So on September 20th, 2016, Chicago Cubs baseball tickets for upper deck reserved outfield seating at Wrigley Field cost $11 each. Let's write a formula for the total cost T if you bought n number of these tickets. So we don't know how many of them we are going to buy. We know we are using the formula for total cost. You take the value of each ticket times the number of tickets you're getting. So we do not know the total cost. We do know the cost of each ticket is $11, and we're not too sure how many tickets we will be purchasing. So we use another variable n for n number of tickets. And that's how you can write a formula. We can perform unit analysis to make sure that the formula we've written is correct. Keep in mind, when we perform unit analysis, we should get the same variables on both sides. So if you think about T equals 11 times n, we want to make sure that they have the same units when simplified. So total cost, that's talking about dollars. 11, that's also talking about dollars. But it's the amount of dollars you're spending per each ticket. N stands for the number of tickets we get. So when you have the same variable in the numerator and in the denominator, like we do, tickets on top and on bottom, you can put a 1 under that, and these cancel right out. So what we have on both sides is we've got dollars on the left, and now on the right we just have dollars. So they have the same units, and that's what we expect to happen when we perform unit analysis. Another common use for writing a formula would be to actually evaluate it. So it says substitute 187 in for T. So we're going to go up to our formula for T, and we're going to plug in 187, and we're going to solve for N and explain what that means in the context of the problem. So 187 in for T equals 11 times n. We're trying to figure out what n is. So to get n by itself, oops, sorry, it looks like my Notability just crashed. Hopefully the video is still there. Okay, we're close enough to where we were a second ago. So we plugged in 187 for t equals 11n. Again, to get n by itself, we need to get rid of the multiplication by 11, so we're going to divide both sides by 11. So in our calculator, if we take 187 divided by 11, it does come out nicely to 17. So n equals 17, where n is the number of tickets. So what this means is that the total cost of 17 upper deck reserved outfield tickets at Wrigley Field, lots of context here, is $187 because N stands for the number of tickets and capital T was representing the total cost. Let's look at one more example and then I'll pause this video and start another one. So a Celsius temperature reading is equal to 5/9 times the difference of the Fahrenheit temperature reading in 32. We're supposed to write a formula in order to do this conversion. So what I'm going to do is read this as if we were translating it. So the Celsius temperature reading, we're going to use capital C, is equal to 5/9 times, and then we're talking about the difference of two things. So that implies a quantity. Difference means subtraction. The and tells us where to put that subtraction symbol. So the difference of the Fahrenheit temperature, going to use capital F, and 32. So let's write this formula in part A. Capital C is equal to 5/9 times the quantity F minus 32. That's how we can convert from Fahrenheit to Celsius. So let's do a conversion. Let's convert 50 degrees Fahrenheit to its equivalent Celsius temperature. So we're going to take 50 and plug it in right there for F. So C equals 5/9 times 50 minus 32. Remember your order of operations, we need to do 50 minus 32 first. So we're going to take 5/9 and multiply it by 18, which comes out to 10. So 50 degrees Fahrenheit would be the same thing as 10 degrees Celsius. If you have a formula written, it actually makes it a lot easier to use your graphing calculator to do some of your evaluating, especially when they ask for a lot of information. So it says use a graphing calculator to convert 50 degrees, 59, 68, 77, and 86. We want to convert all of them, which we could do like we did in part B for each of those. But let me show you how you can use a calculator. So what we're going to do is we're going to go to y equals on our calculator. We're going to clear out anything that's there. And we're going to let y actually be the C and then x be f. So we're going to type in 5 divided by 9 and then parenthesis x minus 32, where again x is actually f and y is our C. Then we're going to click second and table to get over to it. And remember, we're trying to find 50, 59, so I need to scroll pretty far to find those values. So what you should notice is that 50 degrees Fahrenheit is the same thing as 10 degrees Celsius, and that's actually what we found in part B. So it's looking really good that we've done that correctly. So 50 degrees Celsius, Fahrenheit, equals 10 degrees Celsius. We also want to know 59 degrees, so I'm going to scroll. 59 is 15. So 59 degrees Fahrenheit is 15 degrees Celsius. 68 degrees Fahrenheit is 20 degrees Celsius. Sorry for the sloppy writing. 77 is 25. So 77 degrees Fahrenheit equals 25 degrees Celsius. And lastly, 86. So 86 degrees Fahrenheit is equal to 30 degrees Celsius. And so that's how you can use your calculator to do some of this evaluating. In the next video, we'll finish up these 4 points.